Hi students, in this video we are going to see about Module 1 in Advanced Computer Architecture. Let us go to the topics. So, the state of computing, multiprocess and multicomputer, multivector and SIMD computers, PROM and VLSI models, program and network properties and conditions of parallelisms, program flow mechanisms, principles of scalable performance and parallel processing applications, speed up performance loss and scalability analysis and approaches are the topics which we included in Module 1. So let us see one by one. State of computing. This state of computing, it starts from the topic of generations of computer. So we already have discussed the generations of computer. It is divided into 5 generations. So in the first, it's starting from how this generation is divided means based on the durations of years. So the first generation falls on the category of 1945 to 54, and the technology and the architecture what they have used in the first generations are vacuum tubes and memory relays, and the softwares are like low programmed languages like machine language and assembly languages. And what is the system, example system they have used in that kind of generation is ENIAC and then Princeton IAS. So what is the disadvantage in this first generation means, because we vacuum tubes are very costly and they will be fused very frequently. So in the cost wise and also the implementation wise, it is more expensive. So that's what they move on to the second generation. It falls on the year duration of 1955 to 64. And what is that architecture they have used means, they have used some core memories and some floating point arithmetic IO processors. So before that they have used some vacuum tubes, then they have changed on to the some relay memories. And then what is the language they have used means high level languages. The example representative systems are IBM 7090 and CDC. So this in this also they have faced some disadvantage. Then they have moved on to the third generations of computers, where the what is the exact architecture and technology they have used means they have used some ICs. ICs are nothing but integrated circuits. So in the first lowest versions of ICs starts from SSI and MSI. Then what is the programming technology they have introduced on those duration means microprogramming and pipelining. Then coming to languages, so they have used some time sharing OS and multi-user applications, and the representative systems are IBM 360/370. Then move on to fourth generation, it falls on the category of 1975 to 1990. Then the technology they have used as VLSI technology, very large scale industries, and they have used semiconductors. And then what is the OS they have used means multiprocessor US, and languages are some high level languages C, C++ and Java, like that they have used. And then what is the representative systems they have used means VAX 9000, CRAX, XMP, IBM 3090. So this is about fourth generation. Now the fifth generation also derived. So it starts from 1991 to present years. So what is the technology and architecture they have, what we are using nowadays means advanced VLSI processors. Say for example ULSI also we are using. What is meant by ULSI? Ultra large scale industries. And what are the present actively used processor they have used means superscalar processor, system on a chip, massively parallel processing, and grand challenge applications for heterogeneous processing. So these are the some of the processors they have used. So these are about generations of computer. Then after the generations of computer, we move on to elements of computer. What are the basic primary elements of one computer means, let us see the right side diagram. First we will start with the computing problems. So what is the nature of our computation? So it starts from the scratch. So computing problem is our first element. According to the computing problem, what we are going to design. So when you are going to design the solution for computation, so we'll go with algorithms and data structure. Then this algorithm and data structure, in which platform and which language they are going to implement is the next element. So that's what high level language is the next link. So these are interconnected with computer, because high level language, say for example C is a high level language, but in order to implement high level language it should be supported by the hardware. So this hardware resources everything and all circled here, so it is all linked, interlinked. That's what the arrow marks are coming near to this. So what are the basic primary elements of computer means? First one is computing. It starts from computing the problem and designing algorithms and data structure. Then it goes to the definition of high level languages supported by hardware resources. When you get into hardware resources, these are divided into three, not divided, these are is a part of three elements. What are those? Means system software, application software and operating system. We know the meanings of everything: system software, application software and operating system. So these are the internal inherent element of one hardware. Then coming to compiler support, because we already designed one high level language which is supported by hardware, and this should also supported by compiler. So according to this, so these elements are considered as primary elements of a computer. Now we move on to each elements one by one. So computation problem. Computation problems, when you get into computation problem, we will classify the problems into three major categories. So first category may be the numerical problems. Numerical problems, how we can address? We can use floating point computations. And for alphanumerical problems, next case is alphanumerical problem. How we can address these problems means using large database management system and information retrieval computation system. That means IRS are nothing but information retrieval systems. So this is the second category of computing one problem. And third one, what we are nowadays using are artificial intelligence. So we know that artificial intelligence is the most highly legal systems. So how we can address this kind of artificial intelligence system means using logical inferences and symbolic computations. So this is the points about computing the problem. Then next one is we now classified the problems. Next is to design algorithms and data structures. Normally when you're going to design a data structure, some deterministic problems, say for example some problems will be already solved, and these exactly will require a regular data structures to implement. But for some problems they won't require any regular structure because they are like non-deterministic problems. So for that what we can do means we can use some symbolic processing. Some artificial intelligence are coming under non-deterministic problems only, because their processing will be case to case, it will vary. So this kind of problems will be coming under the category of non-deterministic problems. Then third one is hardware resources. Hardware resources, we know that what are the hardware resources means processors, memory and peripheral devices are the best examples for hardware. And apart from that, we have some specialized hardware resources which specifically dedicated for achieving the parallelism. What are those means? Special I/O devices. What are the special I/O devices? Like display terminals, workstation, optical page scanner, magnetic link character or recognizer. So these are the special I/O devices and peripheral devices which mainly dedicated for doing some parallelized processing. So these are the coming under hardware resources. And then system software support. Systems, we know that system software means what are those points will come into our mind? Compiler, loader, linker, pre-processor. Exactly the same thing only we are going to focus now. System software support. So first, what is the main role of compiler? Compiler will generate the machine operation, will convert the machine operations in, will generate the machine operations corresponding to your high level operators. Say for example in C language you are going to add two numbers, means a plus b is equal to c is the exact operation which is written in a high level language. C programming means this compiler, once you are compiling the C program, this compiler will compile the exact machine C programming into opcode, mission opcodes. Why it converts the opcodes means, as we know that the hardware only recognize the mission codes. So this is the main task of compiler. Then similarly loader. What is the use of loader? Loader only it initiates the execution of your program with the help of OS kernel. So these are the important two parameters which we should be supported when you are going to write a program and you are going to achieve the parallelism. Then apart from that, what are the compiler supports which will be upgraded for achieving the parallelisms? So what are those means? Preprocessor, precompiler and parallelizing compiler. So preprocessor, what is the use of preprocessor means? It uses the compiler and low level library of the target computer to implement high level construct. So once again I am repeating, it uses compiler and low level library. So preprocessor, first it will use the compiler and low level library of your computer to implement into high level construct. Okay. So then precompiler. So precompiler in the sense, it depends upon some flow analysis. Say for example, you are going to execute 3 tasks at a time, means we need to analyze the flows of each processing. So one task may require the result from another task, one task waiting for the resources to get. So similarly these processes are interlinked process. That time what we need to do, the flow analysis. So that kind of work will be left to precompiler and parallelizing compiler. So the same thing, parallelizing compiler is an upgraded version of precompiler. So it mainly focus on parallelizing and vectorizing your source code. So what is the source code? You may be writing the source code for executing your task in a parallel main means. So it will be analyzed and it will be implemented with the full parallelized mode. So these are the main importance of elements of a computer in a computer architecture structure. I hope you understand. I will catch you in the next video about next topic. Thank you.